Hi everyone. This talk might have an unusual combination and a strange ratio of both code and artwork. Before we begin, how many of you are verse programmers? And how many of you code on a weekly basis, be it low level programming or visual scripting? Cool. And how many of you consider yourself more on the artistic side? Okay. This talk is about shedding light on the verse programming language from the standpoint of a person with a background in both art and technical fields. For those who don't know, Verse is a very new creation of Epic Games, unveiled at GDC 2023, and Epic Games has plans to integrate Verse in Unreal Engine 6. Okay, some of you may be wondering, what's the deal with a childlike perspective? So my goal is to present a fresh perspective on Verse, and by fresh, I mean an approach that diverges from the conventional focus on syntax and semantics typically found in technical literature. So instead, I will illuminate the language inception, its foundational principles, its underlying motivations, its potential, all through the lens of a non-programmer. My hope is that upon completing this talk, you will grasp the distinctiveness of Verse and recognize its value, even if some of you are not professional programmers. And while doing so, I'll be using many fun illustrations, blank memes, repurposed memes, etc., hopefully to kindle or rekindle your curiosity about this one of the youngest languages on earth, tricking you into learning more about what it is. For example, you may all know about this success kit here in the center, but there is also the failure kit on the left, whom you might have never heard of, and who deserves even more spotlight in the world of verse. And we will learn why. With the release of Epic Developer Assistant, an LLM model specifically fine-tuned for verse and UEFN, how to write verse is getting easier and easier. The AI is really good at giving you solid verse code following your request. Now, creators only have to concern themselves with what idea to implement, or probably why their scripts aren't behaving as expected, not because of syntax errors, but because of logic errors. This is when understanding of verse from above is particularly helpful. So, first, let's just clear up some common confusions people have about verse. Many people I talk to think that verse is a Fortnite only language. Is that true? The short answer is for the time being, yes, you must have to go to UEFN and use it. For the upcoming future, no. Another point to clarify, most likely Verse is not going to replace Blueprints or C++. It's expected that we're going to have all three of them in Unreal Engine 6. I love C++ and I love Blueprints, but today is all about Verse. My name is Juan, and I'm a technical art director. And given a rather unusual approach of the talk, I would like to share a bit about myself. These are some of the productions that I was involved in. I worked at Virtuous for 7 years. These are some of my, There are some of my former colleagues in the room. Thanks for coming. During my time at Virtuous, besides working as a technical artist, I also developed full-fledged asset management software. And this software has been used by hundreds of artists, producers, directors, and at Spark for the production of many blockbuster films and AAA games. At heart, I'm also an artist who loves figurative sculpting and animation. Additionally, I'm fascinated by how effective teaching can transform people's minds and careers. I have taught artistic anatomy, character rigging, and Python scripting to many students. There are a couple of my students in this room as well, so thanks for coming. I'm also a lifelong learner. I have taught myself C++, Rust, and recently Verse. Since joining the Unreal Fellowship Americas for Games last year, I want to share how awesome Verse is for the future of game development. I would like to attribute illustrations in the slides to these dear artists and animator friends of mine. These are what we're going to talk about. We will start with some of the things you should not do in Verse. Then we will see what Verse can do for you and why Verse is not just another new language, why it is not necessarily easy to learn. And finally, we will briefly look at the history that leads to its advent today. So, some of these recommendations are from the official Verse type guide. But just by looking first at what not to do, you will discover how Verse is different from other languages. After a long, arduous trip to look for a guru on an isolated, mysterious mountain here in Indonesia, you are yearning for the moment when he will hint at a Tao verse for you. Let's carefully listen to his teaching, shall we? The first function, get maybe x, returns an option while the second function returns X directly. It may manage to do so, or it may fail. If you're not familiar, an option type in programming acts like a box that may or may not hold a value, and you will always have to unwrap or unbox it to pick inside. Options are super helpful, but when you return an option, you force callers to manually deal with unwrapping. However, Verse has this concept of failures context, and in fact, it uses failures as control flow. So, depending on circumstances, instead of giving back a result in a wrapped option, you can make your function failable with a decides effect specifier. Then callers can easily use your function more idiomatically in other failure contexts. So we just received the guru invaluable teaching in the Tao of Verse. Listen carefully and you realize he's telling you that in this world, not only is failing okay, sometimes it's even better than returning. Now that you have learned how to decide to fail, let's say goodbye to the master for now. Get out of the mountain and learn how to build a game with Verse. When you first start going through some UEFN build a game tutorials, you will see a common pattern of subscribing events to functions or callbacks. This is essentially the event dispatcher in Unreal Engine. Event dispatcher is great as it offers you great flexibility. The transmitter or the sender carries a message and the receiver has total freedom of what to do with that message. However, anyone who has ever pulled their hair out trying to track down complex sequence of message passing will understand that this flexibility should be used with moderation. Not only that, sometimes forcing many local things to actively listen to a global event does not seem logical. So in this example, inspired by Conan Rice, we have the action of tourists surfing around the island and another action of an impending volcano. The surfer's mission is, before the volcano erupts on countdown, to disturb a troll on the island so that the potion she's cooking doesn't reach 1,000 years old. These things take place simultaneously, and a logic weaves through them, which are very common in games. And before Verse, usually in the code we have to tell our tourist pawns, our tourist components, hey tourists, remember to look out for a volcano eruption. That's when the game is over because you will all die. Or even more ridiculously, if you think about it, like telling the volcano, hey volcano, on eruption, use all these individual pieces of person die callbacks on the tourists have subscribed to us when the trip first started. So what if at the language level we could effortlessly express the interaction of these concurrent actions? I repeat, at the language level, not some shenanigans that you have to do yourself. And guess what? Verse has just that. If you raise multiple continuous operations with each other, the first one that finishes automatically cancels all of the rest. This makes more sense, doesn't it? We as developers are granted back the ability to stage concurrent events in a sensible and natural manner, just like in real life, instead of having to maneuver strictly in accordance with how the machine thinks. You see, subscribe does its job, but time flow control can be much more concise, intuitive, and less weird in this case. That failable expression affects specifier, subscription, and concurrency trickiness and whatnot. They are a little bit much. Is there something simpler or more relatable? Let's look at the lighter one. Usually, when you need to do some processing with a type, you will write a function to do it, and over time, your code is populated with lots and lots of single parameter helper functions. There's a elegant solution to this issue in Verse, quite similar to C#, called an extension method, with which you can add functionality to an existing type without modifying the original type's source code. So instead of making a function called zombify, taking a single argument of type human, which is f of a here, you add a method zombify to the type human here, so a.f. And when you do that, the method will also show up in IntelliSense suggestions, so that's handy. First, implementation of extension methods offer a liberating way for developers to enhance existing types without direct modifications. That was a simple do and don't. Before we go to our last thing to avoid, let me ask, does anyone here not know for sure what a synchronous function is or why we need a synchronous function at all? Nowadays, you hardly can do game programming without async. If you fall into one or more of these categories, async programming may seem like a mind-blowing concept to you. Let's slow down a bit here. In plain terms, what is async? Basically, anything that doesn't complete its execution right away should be treated as asynchronous or async. Like this here doing live streaming, it's gonna take a while that the audience don't even know when it's gonna end. So here, live streaming must be an async. I use async all the time in Rust and JavaScript and Dart, but I didn't know of such a simple explanation until I learned Verse. In Verse, you indicate async functions with the suspense specifier, making it clear that the function does not return immediately and takes some time to complete its work. Then you call it just like calling any other function. Here's one surprise. Unlike Python or other languages where async is an afterthought, async is woven deep into the very fibers of Verse. It's not just a feature, it's a fundamental aspect of the language. Take this. Wait, is Ohio mean with you? And next time some noob exclaim, wait, there's superb support for async inverse. You then can murmur, always has been. So no need to decorate your function with async and then names. Follow the tail of specifiers instead. That wraps up our list of the things you shouldn't do in verse. Having navigated the initial prohibition, we now turn our attention to a more practical and immediate exploration of verse by raising the questions, what can verse do for me? The benefits of verse can be broadly divided. On one hand, we have ergonomic advantages that simplify development. On the other hand, there are more profound benefits related to its ecosystem, interoperability, and runtime stability and resilience. I know, that sounds really vague. Ain't anybody ever bothers themselves learning new syntax just for the ambiguous offering? So imagine you were in charge of the public relations for Verse. What would you do to make Verse as a language appear less nebulous and impalpable? You make it look like a tangible object, like turning it to a device. To many people, this is what the first mental image of what you can do with Verse. To think of it as a hub, a place to connect all or most of your creative devices in Fortnite. But this top-down usage is a thing of the past, and it even obscures all that Verse has to offer. Verse addresses the game industry's need for standardization and scalability, much like Pixar's USD, Universal Scene Description, does for 3D animation. Unlike USD, which focus on scene description, Verse uniquely incorporates gameplay logic and runtime execution. It aspires to become an open standard for the metaverse, offering a similar potential for unification and standardization as USD, but with the crucial addition of robust gameplay support. If you didn't, check out the latest wonderful UFO abducting cows example in UEFN. The example shows how easy and effective it is to use SceneGraph for both setting up assets in a composable way and enabling gameplay logic in them. This isn't happening overnight, but Unreal is moving away from its historic model of actor and child actor. I know some of you can get nostalgic or infuriated already. Actor and child actor are working fine. Why do you always have to make things so complicated? SceneGraph allows for easy traversal and manipulation of scene hierarchy, simplifying organization and management. In this new scene graph system, essentially, you only have to deal with components and entities because prefabs under the hood are also entities. Scene graph is also a place where the beauty of Verse shines the most. You are encouraged to no longer place code in centralized locations of Verse devices, but to spread your code to many components. Your Verse components can query into the Odin entity, access other sibling components like material, light, animation, VFX, and modify them on the fly. I hope by now, with the sync graph feature getting out of experimental and into beta, you have realized how powerful Verse is or will be when combined with SceneGraph to construct and allow for complex scenes with complex runtime interactions. That's good news. And Verse doesn't only set out to solve new problems, it also aims to alleviate existing problems. A source of confusion for beginners when first getting into programming is that in most imperative languages, they are the order of statements and the word of expressions. An expression produces a value, while a statement doesn't, but still creates some side effects. Being a functional programming language, there is only the word of expressions in verse. So everything in verse is an expression. You no longer have to worry about is that a statement or an expression? Does it produce any value? Therefore, you can compose the expressions together for complex computation. That's also why implicit return in function is a recommended convention, similar to Rust programming language, because everyone expects that you will give back some result. Through programming, we conduct changes, hopefully in a manageable fashion. Changes are hard, and how a language handles changes is a very important language design aspect, as not only does it affect the efficiency and safety of your code, but also your thinking when you code in that language. Mutability is neither good nor bad, but it makes code more difficult to reason about. There are quite many articles about this topic with elaboration on the net, and I recommend you check them out if you have been having difficulties dealing with mutability. So, in short, mutability is a source of many faults in code, especially when we need to divide the work to take advantage of concurrency, for example, to achieve parallelism. Ensuring correctness with mutable data under concurrency is a very difficult problem, fraught with issues like data races and deadlocks. Many solutions, complete and partial, have been developed over decades to address this challenge. I'll save some of you from the jargon such as mutex or mutual exclusion, channel or message passing, arc or atomic reference counted, or read-write locks, etc. But these are an overview of the approaches taken by two famous languages, Rust and C++. Verse naturally isolates areas with mutability and side effects, making code easier to understand and debug. Combined with its immutable by default, transactional nature, and unique concurrency approach, Verse make your code much safer and simpler to trace. Solutions for concurrent mutability exist in modern software languages, but games has unique challenge. So how does Verse specifically benefit game development? As one of the newest programming languages, Verse learns from the mistakes of its predecessors, incorporates the best thinking models, and provides an outstanding solution for concurrency. While it boasts many great features, this is considered the most refined and dependable aspect of the language. To fully appreciate Verse solution to concurrency in game programming, we need to talk about how game programmers have to deal with time in game engines. Does anyone here not know what a tick is? Traditionally, game programming requires you to think about your implementation in terms of ticks or updates per frame, changes that occur in a single, instantaneous moment of time. Ubiquitous as it is, this approach is counterintuitive because it doesn't align with how the human mind perceives time. Going back the history of computer science, in his famous lecture of the 1977 Turing Award, John Backus criticized the von Neumann bottleneck for its word at a time computation, where word refers to a fixed size piece of data that the CPU processes in a single operation. The solution to this problem is, as Backus proposed, is functional programming that helps us to think in terms of conceptual units like actions and operations. I see an analogy to this von Neumann bottleneck in game programming, and that is the problem of thinking in ticks instead of in conceptual units. Remember all the times you are presented with conditions in the form of event A or event B, or event C and event D. To give an instance, like we are leaving Bali only once Unreal Fest is over and only after going surfing for at least a day, or the rental agreement ends either after 12 months or 30 days after the tenant gives notice, whichever comes first. Those time logic scenarios are very common in real life and also in game development, frequently required in implementations. These time-based conditions can be challenging to handle cleanly without native language support. With Verse powerful capabilities, you can express time logic in a more natural way, giving you fine control over both setup and teardown. Verse concurrency allows you to manage not only how processes should start, but also how they should be canceled and cleaned up. It'll be more straightforward to see this through an example. And to bring the idea of stage direction home, what is more illustrative than the fable of the hare and the tortoise? The analogy of the tortoise, slow but steady, and the hare, fast but naps, demonstrates concurrency patterns perfectly. Verse provides several concurrency and time flow expressions for running async tasks in parallel, controlling how and when each part completes. In this example, I want you to not concern about the actual code. Let the AI do that for us, but only focus on how effortless the implementation can be, even with designed complex staging in verse. This raised expression of verse is verse superpower. As soon as there is a winner, all other competitors will be cancelled, and it'll give you back the result of the winner. We are doing two concurrent operations here as a showcase, but you are not limited to two. You can imagine when there's a third track here of a wolf simultaneously blowing the three pigs' house while the hare and the tortoise are racing. If the action of the house being blown away finishes first, then the hare and the tortoise race will be cancelled instead. In contrast, if we put those same actions of the tortoise walking and the hare hopping in a sync expression, that means we'll wait for the hare, even if the tortoise wins first. And the sync expression gives you a tuple of all member results. Let's just wait for the tortoise to finish his race here for a bit. I'm gonna catch my breath. So this is like a teamwork race. Right? You receive a tuple of all the member results. And what makes me so excited is that verse has even more time flow expression to suit your gameplay logic needs. To reiterate, the benefit of not thinking in the same terms as the constraint related to computer machinery is that it allows us to reason about our programs in a more abstract and high level way. So, in terms of mutability, you don't have to think about everything in tiny state changes anymore. And in terms of time logic for gameplay, you don't have to think about everything in ticks anymore. This alludes to a more declarative nature of verse. You can focus on expressively describing what it is that you want rather than relying on a lot of boilerplates to specify the step by step instruction to achieve the same result. However, to truly power metaverse interactions, the discussed features alone aren't sufficient. The language must also be inherently safe. For the metaverse, a language must maintain consistent simulation states. Like game interactions that revert if a step fails, verse use transactions. Operations within verse are atomic, meaning any failure undoes all changes, ensuring data consistency. The transact effect is used to mark functions where such rollback behavior is desired, particularly when mutable variables are modified. A delightful revelation, wouldn't you agree? But this barely scratches the surface of verse capabilities. Behold the extensive roster of its further uh, capacity. And let's save these as future questions for in your next encounters with the guru. A common tendency in many verse tutorials found online that may potentially hinder the adoption of verse is the inclination to teach it by first going all over feature of imperative programming in verse and with verse. I believe this has the danger of undermining verse unique strengths. Instead, a more logical approach would be to communicate verse distinctive and innovative programming concepts, highlighting what sets it apart, what additional capabilities users can achieve with it, and most significantly, what cognitive burden it can liberate them from, like compared to language like C Sharp, C++, Python, JavaScript, Lua, etc. So while new programming languages are constantly emerging, Verse stands out. By the end of this section, I hope you'll understand what makes it unique. As a functional logic programming language, Verse offers a more robust and reliable approach to software development. This is a bold move, considering the dominance of imperative programming, which has persisted for over 70 years. Although functional programming is often known for its steep learning curve, particularly with concepts like Haskell monad system, it had gained popularity in recent years for its ability to address the limitations of imperative programming. One positive quality of verse is that it aims to eliminate the perceived academic dryness often associated with functional programming, making it more accessible and practical. If you have been paying attention, you have realized by how I mentioned programming schools of thoughts like imperative and declarative. Imperative programming focuses on how to do something, while declarative focuses on what outcome you want. Modern languages, including Verse, blend both. Verse supports imperative code but leans heavily declarative. For instance, Verse handles concurrency by letting you state your desired outcome, freeing you from managing complex threads yourself. Unlike natural languages, programming languages have clear designers and users. Verse uniquely shifts burdens from programmers to its designers. As Tim said, a smart Verse team has permanently solved major challenges developers traditionally faced alone. Memory safety is a huge software problem. Verse, like Rust, prioritizes it, but without Rust complex borrow checker. It offers compile time verification and runtime safety, typically hard in C++ or exclusive to Rust at minimal cost. This might mean garbage collector, overhead, or adapting to Verse, but never at the expense of safety. Essentially, Verse handles memory safety for gameplay, and you just need to learn its unique style. Talking about style, being a functional logic language, an expression or operation in Verse always produces 0, 1, or many values. A failable expression, if successful, returns one or more values. If it fails, it returns nothing at all, unlike an empty list or a false boolean. For instance, an invalid array index simply fails the expression, removing the need for explicit bounds check common in other languages. Let's see this find function that operates on an array using a predicate. In this example, the loop iterates through elements, returning a match immediately if found. If no match is found by the end of the list, it fails on purpose. This demonstrates failure as control flow, a core concept in logic programming like Verse. Now that we have seen some Verse code, how do we link it to the assets in Unreal project? Unreal's reflection system let user inspect C++ elements and use them in Blueprint at runtime. Similarly, Verse has an asset reflection system, allowing it to access your Unreal assets. The assets digest Verse file is automatically generated, not for you to edit. Via this reflection, you can access and modify asset parameters like UI images or VFX settings. This approach ensures compile time verification, crucial for the metaverse stability. The metaverse needs a language like Verse. Given Fortnite's collaborations, the future of these virtual spaces is promising. Tim's grand vision implies a consistent set of simulation rules even across different virtual worlds within the metaverse. The metaverse is an open canvas. If you find its possibilities exciting, use Verse to build your imagined worlds. While my vision is playful, Epic's Verse team is seriously building it as the metaverse backbone, focusing on thoughtful design and essential features. So, to summarize, Verse is a functional logic language with mathematical integrity designed for the metaverse infrastructure. Its ability to access Unreal Engine assets and many other capabilities makes it a compelling choice for gameplay logic, gameplay programming. Given that one of the design goals Epic Games has for Verse is to make it learnable as a first language, Verse syntax overall has a clean and modern look and feel similar to Python. It appears closer to English and is less cluttered with symbols. Additionally, Verse documentation is relatively well organized and informative. However, inexperienced users who set high hope based on this appearance may find themselves disillusioned when they start to discover the language's deeper layers of complexity. Let's take a moment to prepare ourselves by briefly outlining what to expect. Understanding Verse for API layers simplifies learning. So you have one core Verse. Epic keeps this small engine agnostic standard open for adoption. Two, Unreal Engine API specific to Unreal, like UI and diagnostic. Three, Fortnite API for game elements like players and vehicles. Four, Project Assets API accesses your project's unique assets via reflection. Like distinguishing Python features from Maya specific ones, knowing these layers help you better understand verse code. We alluded to some specifiers in verse. You've seen the decide effect specifier for failure context, the suspense effect specifier for async functions, the transact effect specifier for reversible operations. But those are not all. Verse doesn't merely adopt specifier as C++ does. It seems to set a new benchmark with the sheer number of specifier keyword it employs. This complexity might be off-putting to those who favor the straightforwardness of Python. However, under the hood, the beauty of verse lies in this foundation on denotational semantics, a study that harmonized modern language features with the runtime safety verse guarantees. Unlike Rust, which enforces memory safety through a stringent borrow checker, verse frees you from the intricacies of low-level memory management. In the spirit of the no free lunch adage in machine learning, the extensive use of specifiers is the trade-off for achieving the robust safety and performance that Verse delivers. Remember that Verse is a brand new language created to free us from paradigms that are popular but not necessarily beneficial. It's not just a functional language, it's a functional logic language designed to be different and innovative. It doesn't have to follow the same convention as other languages because it's not trying to be like them, it's trying to be better. When switching 3D software, say from Maya to Blender, users are typically challenged more by new keyboard shortcuts than by the core design philosophy. Similarly, when learning a new programming language, people often get bogged down by the syntax rather than understanding the underlying concepts. Therefore, it's helpful to loudly clarify some of the biggest mixed syntax confusion now. These are three different meanings of the question mark used in verse. The question mark can be used to declare an option type, to query a logic value or an option, and used to signify a named argument. If you come from JavaScript and are familiar with the various use of the question mark operator, you'll have a head start. Don't worry about memorizing them yet. Just being aware of these different meanings will smooth your learning path with verse. Do you know how many languages before verse also have square brackets for function invocation? Very few. It's easy to be deterred by small, strange things like the use of square brackets in verse, like this. But it's all relative to how we are used to manually checking return values. Other languages have a similar concept in error handling with their result type. Verse just takes the notation a step further to make it more explicit. Here's a funny one that I just want to throw out there. This is not syntax, just verse convention. So you use snake case, lowercase with underscores for classes and types, and Pascal case, upper camel case for your variables and functions. While this convention may seem odd initially, it's minor compared to the rabbit holes you might stumble into as you explore verse further. Diving deep into verse reveals quirks. Filters don't return booleans and types are also functions. This requires a mental shift for imperative programmers. But while challenging, try thinking that these unique aspects are what you deserved. Given verse numerous benefits, especially for game development, the learning curve is well worth it. You've seen what verse can do for you, its uniqueness, and even some of its peculiar facets. Now, let's put things in a broader context. Let's try to understand why Tim Sweeney and Epic Games are spearheading this monumental task of designing and realizing a new language ambitious as verse. Verse has a surprising precursor, part of a long, positive struggle in computer science history. As a prelude, I recall a quote from DM GUI's GitHub. Give someone state and they'll have a bug one day. Teach them how to represent state into separate locations that have to be kept in sync and they'll have bugs for a lifetime. While immediate mode GUI helps with mutable state in UI, the broader issue of mutability remains challenging. The challenge of mutable state, especially with concurrency, and the von Neumann's bottleneck neck are well known in both academia and industry. If you follow recent tech discussion, you'll know imperative programming isn't the only solution. Functional programming, a powerful alternative rooted deeply in mathematics since 1936, offers a safer, more robust foundation by emphasizing immutability and declarative style. Unlike engineering marvels that can be buggy, functional languages like Haskell, based on Alonzo Church's elegant lambda calculus, provide formal correctness. Despite its advantages, functional programming's slow rise to immense success is a valid question, often linked to the unique story of Haskell. From the many functional languages of the 60s to 80s, only a few like Lisp, Scheme, OCaml, and Haskell survived. Building a mathematically sound yet useful language is tough. Haskell, a committee designed language, was groundbreaking, but initially struggled with basic I/O like printing of file operations. A language, regardless of its ideas, needs to be to do basic tasks. Consider this described by Simon Peyton Jones, a former research scientist at Microsoft and now an engineer fellow at Epic Games. The graph illustrates language safety versus usefulness. Languages like C++, Java, even Python started useful and aimed for safety, which is the plan A, like moving horizontal. Haskell, however, began incredibly safe at the bottom, but needed to become more useful, plan B. For a long time, Haskell model was avoid success at all costs, a humorous jab at its initial impracticality, while they tackle complex issues. Recently, Haskell's success proves functional programming is now truly capable, a major win for the software industry. So, past impossibilities now seem resolvable, and what once appeared useless or like dead ends now are proving fruitful. Previously standard yet problematic methods are gradually becoming obsolete. Programming isn't renewed by new paradigms, but by overcoming old hurdles, removing limitations, and fulfilling long-held dreams. This brings a sense of wonder, curiosity, and a childlike perspective to the field. We've explored verse benefits, history, and unique traits. A key influence is its departure from hardware-bound imperative thinking rooted in the von Neumann architecture, which Tim Sweeney sees as limiting. Tim, with single-mindedness, wants verse to be hardware agnostic, conforming only to universal math. He believes its fundamental design means even advanced alien civilization could appreciate it, seeing similarities to their own programming. With Tim Visions, perhaps verse could single-handedly save humanity from alien abduction. Advanced alien might value its mathematical integrity over our engineering marvels. New AI tools means your verse knowledge could unlock opportunities, potentially securing jobs and our freedom. So go learn you a verse for great good. Thank you. Okay. I think we have quite plenty of time for questions. Yes, please.
Thanks for the talk. Not at all what I expected, which is a good thing. So yes, I agree with what you said that there's ways of introducing a new language that might put off the people who are going to come up with amazing new ideas on how to use it. Are there any UEFN islands that demo really interesting uses of verse that you could recommend that mightn't be so obvious?
I think the latest one, because thanks for your questions and your remark. I think verse is better appreciated when you see it in the context of scene graph as well. So with the recent very new 5.6 example, in UEFN, the scene graph example, like you can just download it. You can see how they incorporate verse components into entities and enabling that UFO abducting cows. I recommended that one because in the past they released a scene graph example which I dabble with, but and then they withdrew that. But now there's a more um, more stable scene graph example, and you can see how verse can be put into context.
Thank you. I'm curious, has Tim, if you will, shared how do you sort of like anticipate the changes beyond, let's say, UE6 in terms of verse integration? Like, how far is it going to go in terms of, I guess, really influencing, I guess, how blueprints are used, how C++ is used? Is there any indication from the development team on where it's all going to end up? Like, how far is it going to push that?
Oh, that's a very good question, and actually, I don't know. Yeah, I'm curious about that myself. But seeing talking to the language team in Orlando, I think as I alluded to, they are exploring a lot of directions. I see in how they can push it further. But um, it's already functional in a lot of like Fortnite gameplay. Um, but Fortnite is a maybe a very different story from other types and genre of games. But yeah, I'm excited. I'm curious about that as well. So I have no idea. Maybe I will.
Thank you.
Yeah, thank you.
Hello. So, what's the current interoperability between Verse and C++? So, like, can I mix C++ and Verse in the same project, or maybe if I have a library in C++, can import it to Verse and vice versa?
Thanks for your questions. Actually, that's a I don't know that myself either. But the way that I imagine it, I'm not representing Epics, but the way I'm imagining it, you won't be able to mix Verse and C++ for quite a while. I mean, if your C++, like in the custom engine part, you might use Verse as a high level for gameplay and such, but not as a FFI like interaction, right, in a deeper layer. I personally don't think so, and I assume so.
Would the same also hold true for Verse and Blueprint?
Yes, I assume so as well. Like they like at least for a very near future, because uh, I think they're gonna have a lot of breaking changes, and they want to keep verse separately. I assume they would want to keep verse separately for a while from C++ and Blueprint, but actually that's a quite interesting matter because in UEFN um, sometimes you hear that you can't use blueprints in UEFN, but the fact is that you can use it to some extent. Like you can still make some blueprints in UEFN. So and like you still can use control rig and some features, but not the animation blueprint um, to the same extent in Unreal Engine. But I I think it's gonna be separate silo for quite a while for a new future.
And one more question. How much control Verse is giving us when it comes to memory management? Like, can I provide a kind of fancy allocator?
I don't think so. That's the point of very declarative function. They instead of having to deal with like, memory allocation and destructors. There's no destructor in Verse. It automatically can clean up things for you. So you just describe what you want. I know, like if you like very proficient with that kind of thing, that like Verse approach seems really strange. But the point is like you will have more time to focus on describing the interaction in your game instead of having to dealing with like low level intricacies of threads and like multi threading stuff. Yeah. So I don't think there's low level management like Rust. Like you won't have to allocate fancy memory type as data structure. Yeah,
Thank you.
thank you. That's a very good question. Mhm.
I'd just be interested in your thoughts on this. One of the things that I've always found a bit not hypocritical but contradictory with the whole concept of verse is that when you kind of listen to the vision for it, it seems to me like network and interconnectivity is really at the core.
Mhm.
And yet, so at the moment, you can't interoperate with any other system. It's just the world of Fortnite. So, I mean, what are your thoughts on that? Do you think we're not even at version 1? Because it feels to me
Mm.
like verse doesn't mean anything until there's non-Fortnite
Mm.
worlds to interoperate with.
Yeah, that's a very good um, yeah, very good question. I personally, I think um, like Fortnite is a gigantic multiplayer networking games, and I think Epic is exploring. I mean, I the way I see it is replication and networking will automatically handle, but the way Epics usually implement with battle tested mm, like uh, massive games, online games, and the language will like handles all of that low level stuff for you, so you won't have to manually deal with that. But my take is liberating for outsiders, um, especially who don't have that expertise to handle all that really complicated um, networking stuff. Um, yeah, so I personally I think that's refreshing. Thank, all right, I think that's it. Thank you very much for coming.